Hello everyone, welcome to Shiv's classes. In today's lecture, we are going to discuss problem number 4, 5, 6 from the Miscellaneous Exercise, which is part of Chapter 3. And this chapter is called Trigonometric Functions. We have already discussed quite a few problems. So today we are just going to start with problem number 4. And prior to starting that, I would just want to remind you of certain formulae which you would be needing in solving this problem. So this time around I am not going to write down the equations, but rather I have already noted down so that the video size becomes little less. Alright, and then you could just watch this video quickly. So these are some of the formulae which you might have seen already in your book. So first formula is sin square x plus cos square x plus to 1. Then we have cos of a plus b. Then we need to know cos of 2 theta and 2 theta in two forms probably. One in cos square theta form and another in sin square theta form, and then this evergreen formula of cos c plus cos d, which we will be making use of pretty often, and then sin c plus d. So these are some of the formulae which we'll be making use of. So now let's start with the exercise first. So this is my first question. We need to prove there is something given on the left hand side and we need to prove something on the right hand side. This is just similar to the problem which we have done in the previous video. We had in previous video the similar kind of structure, and we had to prove that to 4 cos square x plus 5 by 2 or x minus 5 by 2. So we'll start in the same manner. What we will do is we will write the equation first. So our LHS is cos x minus cos y whole square plus sin x minus sin y whole square. Now since this expression is given, what we will do is first we will try to expand it and see if there is something getting cancelled out or becoming 1 or something, right? We'll write it down. We'll have cos square x plus cos square y minus 2 cos x cos y. So why did that happen? So because we know the formula a minus b whole square is nothing but a square minus 2ab plus b square, right? So this is what we have done. This is a, this is b. If this is a, this is b, then I have a square plus b square minus 2ab. Similarly, this is also a minus b whole square. So we will expand it and have sin square x plus sin square y minus 2 sin x sin y. Alright. Now I can club cos square x and sin square together, and I can have like cos square x plus sin square x. So why we are doing that? Because it will become 1. I know that this is the formula of sin square x plus cos square x. Similarly, cos square y plus sin square y will be clubbed together. So cos square y plus sin square y, right? And here I have minus 2 cos x cos y and minus 2 sin x sin y. So I'll just take minus 2 common, and then it will become cos x cos y plus sin x sin y. Now look at this one as well separately. This is cos x cos y plus sin x sin y. This is nothing but the formula of cos a plus b. No, it's not formula of cos a plus b. Rather, you should have a formula of cos a minus b as well. And then in that case, what would the formula of be? It will be cos a into cos b plus sin a into sin b, right? So you just have to be wary of the sign over here. If it is positive, then it is cos a minus b. If it is negative, then it's cos a plus b. Alright. So now this has become 1. This has also become 1. Now I just mentioned this is the formula of cos a minus b or x minus y. Alright. So now I have got 2 minus 2 of cos of x minus y. Alright. Now let's take 2 common. What do we have then? 1 minus cos of x minus y. Now what we have on the right hand side? We have something like 2 sin square x minus y by 2. Alright. So you can see there is something like this over there, and and it's x minus y by 2. So if we can treat x minus y as something like a 2 times theta, if I treat x minus y 2 times theta, then cos 2 theta is nothing but 2 cos square theta minus 1 and 1 minus 2 sin square theta, right? Or 1 minus cos 2 theta, if I have to just rearrange this formula, if I rearrange this formula, I will have 1 minus cos 2 theta equals to 2 sin square theta, right? And let's assume x minus y is equals to 2 theta, then this will become what? 2 into 2 sin square theta, and theta would be what? Theta would be x minus y by 2. So that's what I will write, 2 sin square x minus y by 2. Alright. And now this has become what? This has become 4 of sin square x minus y by 2. And this is what we had to prove, right? So this is just simple application of formula. Some of the formulae which you remember, if you remember, you will be able to solve this very easily. So first you expand it, make this 1 and 1, then you have to make use of another formula, and then you will be done here. So as I mentioned, there will be application of 2 or 3 concepts together in miscellaneous exercise, and that's what is happening here. Now let's move on to the next problem. So our next problem has got sin x plus sin 3x plus sin 5x plus sin 7x, and we have to prove on the right hand side 4 cos x into cos 2x plus sin 4x. Alright. Now again, as we had seen in the last slide, that sin c plus sin d formula. So if it's looking like there are 4 terms and we need to club 2 of them together, and then we will get something out as well, right? And but while we are solving this problem, we should be looking at the right hand side and try to make sure that we are working with the numbers wherein it becomes easier. So what I mean is, I'm looking at the right hand side, I'm getting something in sin 4x terms, and if I'm applying the formula of sin c plus d or sin c plus d, sin c plus sin d, then what do we get? We get 2 of sin of c plus d by 2 into cos of c minus d by 2. Alright. So this c plus d by 2 has to become 4x. Then only the clubbing will work well, right? So look at x and 7x. When I club them together, this will become x plus 7x, 8x by 2. Similarly, 3x and 5x, when they are clubbed together, they will become 3x plus 5x will be 8x by 2. So yeah, I mean, you could start with these two, but I think you should also look at on the right hand side and then work appropriately. So let's start with this and then start rearranging. Let's put sin x plus sin 7x together, and then put sin 3x plus sin 5x together. And now we have sin c plus sin d, and then we will use the formula. So we'll become 2 of sin of c plus d by 2, which is x plus 7x by 2, into cos of c minus d by 2, cos x minus 7x by 2. Similarly, this will become 2 of sin of 3x plus 5x by 2, and then the next term will become cos of 3x minus 5x by 2. I'm just applying the formula which is given over here. Alright. Now the first term, x plus 7x by 2, will become sin of 4x. Now this will become x minus 7x minus 6x by 2, which will become minus 3x. But cos of minus x, we know that cos of minus x equals to cos of x. We'll just simply write cos of 3x over here. Then we will be left with 2 times sin of 3x plus 5x is 8x by 2 is 4x, and here 3x minus 5x by 2 will be minus 2x by 2, which will be minus x, and cos of minus x is cos x. So I'll just put that back. Now this 2 sin 4x term I can take out as common term, right? 2 sin 4x. Now I will be left with cos 3x over here, and then I will be left with cos x over here. Alright. Now this is again looking like cos c plus cos d. What is cos c plus cos d? You know that, right? It's nothing but 2 of cos of c plus d by 2 into cos of c minus d by 2. Alright. So this is what it will be. So let's do that. 2 of sin of 4x. We have 2 of sin of 4x. And then again we will have a 2 times cos of 3x plus x by 2. This is c plus d by 2 into cos of 3x minus x by 2. Alright. Now again, this is just a simplification of it. So now 2 into 2 is 4. We have got sine of 4 of x. And then we have cos 3x plus x by 2. 3x plus x is 4x. 4x by 2 is 2x. So cos of 2x. And then we have 3x minus x is 2x. 2x by 2 is x. So we have got cos of x. So let's see what do we have to have on the right hand side. So we have to have cos 4 of cos x, cos 2x and sin 4x. This is what we have to have. We just rearrange it. 4 of cos of x into cos of 2x into cos sin of 4x, which is what we have to prove on the right hand side. Now let's move on to the next problem. Here in this problem you could see that this is again just a simple application of formula. Once you apply the formula, again in the next step there is another formula, and if you apply that, you will be able to get the answer. Just ensure that while you proving it, you look at the right hand side so that your number of steps become less. It is not that if you had started with sin x plus sin 3x and sin 5x and sin 7x, you wouldn't have achieved the same result. You would have also got the same result. Maybe there would be a couple of steps more in that case. Alright. So yeah, now let's move on to the next one, which is problem number 6. And that will be the last form of the day. Alright, so here there is a big expression, and on the right hand side it becomes only tan 6x. And here the clubbing is already done for you. And again, it's looking like some formula like sin c plus sin d, and in the bottom or the denominator it is cos c plus cos d and cos c plus cos d. So we'll just apply the formula and see how it turns out. Alright, so LHS, we have got sine of 7x plus sine of 5x together, and then we have got sine of 9x plus sine of 3x together. Then we have got cos of 7x plus cos of 5x put together, and then we have cos of 9x plus cos of 3x put together. So let's simply apply the formula and see how we fare. So sin c plus sin d is nothing but 2 of sine of c plus d. So sin 7x plus 5x by 2. So 7x plus 5x by 2 into cos of 7x minus 5x by 2, right? And then we have similarly 2 of sine of 9x plus 3x by 2 into cos of 9x minus 3x by 2. Alright, now go to the denominator part. We'll have cos c plus cos d, so this is 2 of cos of 7x plus 5x by 2 into cos of 7x minus 5x by 2, right? Plus 2 of cos of 9x plus 3x by 2 into cos of 9x minus 3x by 2. Now let's simplify it. So what do we get over here? We get 2 of sine, and 7x plus 5x by 2 is nothing but 12x by 2, which is 6x. Then we have got 7x minus 5x by 2, which is 2x by 2, which is cos x. Then we have got 2 of sine of 9x plus 3x by 2, 12x by 2, which is again sine of 6x. And then we have got cos of 9x minus 3x by 2, 9 minus 3 would be 6x, 6x by 2 would be 3x. So we have got cos of 3x. Then we have got 2 of cos of 7x plus 5x by 2, 12x by 2, which is cos of 6x. Then we have got 7x minus 5x by 2, which is 2x by 2, which is cos x. So cos x plus 2 of cos of 9x plus 3x by 2, which is 12x by 2, which is 6x. And then 9x minus 3x by 2, which is 6x by 2, which is 3x. So cos of 3x. Alright. Now again look at the expression. What do we have? Can we take out 2 sin 6x common in the numerator? Yes, we can. So cos x plus cos 3x is what we are left with. And if the denominator we take out 2 of cos of 6x common, then we are left with cos x plus cos 3x. Alright. Now this cos x plus cos 3x will cancel out. This 2 and 2 will cancel out. And then we will be left with sin 6x by cos 6x, which is nothing but tan of 6x. Alright. So yeah, it was just a simple application of formula. And while you take something out common, you get the result what you desired. Alright, so we are done with problem number 4, 5 and 6. If you have any questions, please do ask me in the comment section below and I'll be happy to answer your questions. Thank you so much for watching this video. Have a nice day.